back to Further Solutions Academy. Further Solutions Academy. Don't forget to share and also subscribe. Just help us to share and subscribe. And presently we need a lot of things on this platform. We need bigger board, better camera, even to buy our marker. We need your help. Just contribute little to us. No amount is small. You can meet us on this number 234-80-344-95990. With this number you can call us, you can WhatsApp us, and Telegram is allowed. With these numbers you can do that for us. Now let's continue by, okay, I have this type of question. I want to move on to inclined plane. Before I move to question, let me quickly explain what we understand by inclined plane. Now, when we talk about inclined plane, this time around we'll be going along with what? Sine and cosine, which is sine rule. Trigonometry is allowed here. It means we'll be working on right angle triangle, which is SOHCAHTOA will be allowed. Now, inclined plane, the inclined plane is used to lift heavy load into van or truck. Example: R is slope, hill, a hill, a ram, etc. Now, when you want to lift up a very heavy load to a truck, it means this is what is called incline. That is what is called incline. Now, this is the floor, which is the level, and this is the height. That's what I mean. It means h, and this is what will be what? Now, this is theta. Now, this can be the load that you are lifting, which is on this load, effort. Load. This is the load. Now, that is what we are talking about. Let me put x, y, z. Now, velocity, ratio of an inclined plane is given by VR equals to distance moved by effort divided by distance moved by load. Which also equals to the length of inclined plane divided by length, divided by height of inclined plane. That is what we are forming there. Now, this is the height, this is the length. Anyway, now, so we can say that with what is on ground, we can say that what my sine theta, which is where I stopped on the last video, which is I was trying to summarize, which h all over L, which also can be equals to 1 all over sine theta, which can be equals to 1 all over what? H. 1 all over h. which is when I rearrange it. Now also I can say that my V velocity ratio equals to L all over H, which is equals to 1 all over sine theta. 1 all over sine theta. Now, with this, let's continue. Now, we can say that what again we need to work on. Okay, for frictional, there will be a frictional because of is inclined. That thing, let's talk about the frictional part of it. For a friction, now, or frictionless. For a frictionless, inclined plane, which is V of R, VR, which is equals to velocity ratio equals to mechanical advantage, which also can be equals to 1 over sine theta, which is always equal to. Now, work done, work output equals to load multiplied by distance moved by load divided by load multiplied by height of inclined plane, which also can be equals to L multiplied by H. L multiplied by H. Sorry. L multiplied by H. Now, L multiplied by H, which I can say that this is my L load, this is my height. Okay. I can also say that work input can be equals to effort, the effort multiplied by distance moved by load, which also can be equals to effort multiplied by length of inclined plane. Now, which I have effort multiplied by what? By load, which is small load. Now, which is distance move. I've explained this in our previous video. Before you watch this video, make sure you watch our previous video. Very, very important. Now, what again we need to understand? Efficiency is very important at this point. Efficiency of inclined plane, which is it will be equals to efficiency equals to work output divided by work input multiplied by 100%, which my efficiency equals to L multiplied by H divided by E multiplied by L multiplied by 100%, which I can also narrate as L all over E multiplied by H all over small l multiplied by what? 100%. That's all about that. I think with this we can see how inclined plane look like. How it look like. Now let me try to give 2 or more examples to explain this part. Okay, I have to rub this part. Now, I have this question: an inclined plane of an 15-degree is used to raise a load of 4,500 Newton through a height of 2 meters. If the plane is 75 degrees, 75%, if the plane is 75% efficiency, calculate work done on the load. Now, solution to this question. I have my angle, which is my angle inclined of inclination, which is theta equals to 15 degree. Now my load, which is 4,500 Newton, my height of the plane, which is h equals to 2 meters. Now my efficiency is 75%. Now, which I can now continue by having mine. First thing is the velocity ratio will be equals to 1 over sine theta, which I'll be having 1 over sine 15, which it will be equals to calculator 1 over sine 15. Now, with help of my calculator, now I will be having, with help of my calculator, I'll be having 3.86. Now, since I have done that, to my work done on the load will be equals to efficiency equals to work done, work output divided by work input multiplied by 100%. Now, which I can say that my work input will be equals to work output divided by efficiency multiplied by 100. Now percent. Now I can now continue that my load multiplied by height of the plane divided by efficiency. Now, which I can now say that what L multiplied by H divided by efficiency multiplied by 100, which is percent. We have that, and it means what is my load? My load is given as 4,500 multiplied by what is my height? My height is 2 multiplied by 10, 100 divided by what is my efficiency? 75. Now, by so doing that, you have to use a calculator, and which is it will be 12,000 joule, which it will be 12,000 joule. can convert it to kilojoule, which is 12 kilojoule also, which also the same thing as what? 12 kilojoule. Anyhow you want it. Anyhow you want it. That is all about that. Now, let me... Okay, I have time. There's one very funny question that you have to see, and to be very simple. You can meet it anywhere, and you have to see how it looks like. But the question is very much. I would like to use it as an example so that to compile everything I want to do in this part of this question. Okay, I have this question here. Okay, with this question, it will really explain everything I have to tell you on this part. Okay, it's a very much question anyway. Involves a man pulls up a bus of mass 70 kilograms using an inclined plane of effective length of 5 meters onto a platform. 2.5 meter height, 2.5 meter height, and 2.5 meter height at uniform speed if the fractional force acting on the bus and the plane 100 Newton. Draw the diagram of all the forces acting on the plane, on the bus, rather, when in motion, and calculate one, the minimum effort applied in pulling the bus. 2, the mechanical advantage on the plane. 3, velocity ratio of the plane. 4, efficiency of the plane. And what again? 5 work outputs of the man. 6 total power developed by the man, given that the time taken to raise the balls onto the platform is 50 seconds. Your gravity 10 meters per second square. That is what I have for you. Okay, it's a very much question, which is my hand is paining me while writing, but it will really help us to understand everything on the inclined plane. The first thing we need to do is solution to this problem. Now, with this, it will help me to explain everything on this part. Now, the first thing I will do, I'm talking about height of what? The height is 2.5 meters. And also, this is going to be the plane. And there will be a load on it. Now, this is called effort, and this is called load. We all know that. Now, everything comes there, we call it reaction. That is the reaction. Now, we are talking about the effort and the load, and force will be here. My force will be here. Now, here will be mg sine theta, which is my force is equals to 100 Newton. Now, also here will be mg cos theta, which is my mass. We call it, what is that, my mass? The mass is equal to 70 kg. 70 kg. Now, since I have it this way, what again do I need to? Now, everything is what? Let me now quickly explain. My n, which is my mass, 70 kg, which is, it will be weight, which is multiplied by, now it's now become weight. Anyway, now, since I have it with this, which is my force, my frictional force, it will be equals to, my frictional force will be equals to, which is F, will be equals to 100 Newton. Now, what again did I have there? My G is 10 meters per second squared. What else did I have there? The height, which is my H, 2.5 meter, and the length of the plane. The length of the plane is 5 meters, which is the length of the plane from here to here. Length of the plane 5 meters. Now, the length of the plane is what? Is 5 meters. Now, since I have everything, what again is also on the, okay, everything is now I will now continue by having the load or weight, of the balls, the load or weight of the balls, which is downward. downward, and as two components will be equals to I'll be talking about mg sine theta, which is parallel to the plane, and also mg cos theta, which is perpendicular to the plane. Perpendicular to the plane. Now, since I have it this way, I can now say that what my sine theta equals to h all over L, which also equals to 2.5 divided by 5, which I'll be having 0.5. That is for that. Now, 0.5, it means my sine theta, will be equals to sine inverse of 0.5, which I'll be having 30 degrees. Now, I have to rub the upper part because of the space. Please, we need your help at this point. Help us contribute your F little. Oh, I've rubbed the equation. Okay, now I'm now on the upper. Oh, wow. The first question says that find the object. Now, for the object to be pulled up the plane, it must overcome oppositing fractional force, which is F, and the parallel components of the load mg sine theta. Therefore, the minimum effort will be equal to, which is mg sine theta plus f, which I have. What is my m? We have 70, which is my multiplied by 10 multiplied by sine 30 plus what? 415. Now, which I'll be having multiplied by, which is equals to 415. Everything will be equals to 415. That is for that. The second one, number 2, I'm talking about mechanical advantage of the force ratio, which is load all over effort. Now, we all say that my mechanical advantage is always equals to force all over effort. That's what I'm doing now. Okay, which I'll be talking about now. Force effort over which is I'll be having my mechanical advantage equals to mg divided by effort, which is 7 multiplied by 10 divided by what? 450, which I will be having 700 divided by 450. Cancel, which is I'll be having 1.5 joule. I mean 1.5, 1.56. No joule. That's not right. 1.56. Now the second one, I'll be talking about velocity of the plane, velocity advancing, which is my V number 3. Our velocity ratio will be equals to L all over H, which I have 5 all over 2.5, which I have 2. That's my velocity ratio. The next one I'll be talking about is efficiency. My efficiency, which is number 4. Okay, my efficiency, which is equals to mechanical advantage velocity ratio multiplied by 100%, which I will be talking about 1.56 multiplied by 100 divided by 2, which I will be talking about it will be equals to 156 divided by 2, which is 2 in 15. We have 7 in 15, 8, which is 78. That is efficiency 78%. 78%. Now, and the next one we'll be talking about 78%. Now, energy number 5. Now we are talking about what? Energy lost in the system, which it will be equals to, I need to rub everything anyway. Energy lost in the system, it will be equals to work input minus work output. By so doing that, you get your energy loss. It means E of multiplied by L minus what? L multiplied by H, which I have 450 multiplied by 5 minus 700 multiplied by 2.5. Whatever I have, which is 500 joule. 500 joule. Now, okay, hope it's making sense. The last part of it, which is we are talking about total power developed. Total power developed. Now, total power developed, it will be equals to work output divided by work input. Work output divided by work input, which I'll be having. What is my work output? My work output from the question, it is 1,750 divided by, and so on. And I think that's also, I don't have the question presently available, which is you should get it and get it, the formula done. Okay, I'll be stopping here. Don't forget that you are on with Further Solutions Academy. Further Solutions Academy. Encourage us to share and subscribe. Thanks for watching.